Hello everyone, today we are going to see CR, that is Cauchy Riemann equations. First of all, let's see what are analytical equations. Analytical function, right? Okay, so there are so many functions, trigonometric, algebraic, but analytical functions are something different. Analytical functions are the functions which are not only differentiable at a single point, but also differentiable at the point neighboring to it. Let's say that we have a function such as the inverse function f of x equals to 1 upon x, right? Now this function is differentiable at every single point on the now this inverse function is differentiable at every single point on x-axis, but at a point x is equals to 0, f of x is not differentiable. That means the derivative of this f of x will comes out to be infinite. At this point, where the derivation of this function f of x comes out to be infinite, is called as singular point. And at this point x is equals to 0, the function f of x is equals to 1 by x is not analytic. Now this is the concept of analytical function in an algebraic term, but let's say we have a complex number z is equals to x plus iy, or a complex function such as f of z is equals to u plus iv, where this u and v both are the functions of x and y. Then what we have, how we are going to check their analytic properties. So for that we have the CR equations with us. CR equation says that del u by del x is equals to del u by del y, and another condition is del u by del y is equals to del v by del x. If the function u and v satisfy this two equations, then they are called to be analytic. Now how to prove this equation? To prove this equation, we are using a simplest form of mathematics, that is called as limit. Let's say first of all we have z is equals to x plus iy, and let's make a small increment in the value of z of del z, that is del x plus I del y. Again, let's consider that function we have mentioned, that is f of z is equals to u plus iv, and again a small increment of z plus del z in it. You will have u plus del u plus I v plus del v. This del v are the corresponding small increments in the value of u and v respectively. Now let's say that we are differentiating the value of f of z. So it will be limit del z tends to 0 such that f of z plus del z minus f of z del z. After further proceeding, let's put the values of f of z plus del z, f of z and del z in the equation. We will get f of z is equals to limit del z tends to 0, u plus del u plus I v plus I del v minus u plus u minus I v, where the bracket will open up and the negative sign will go on both the sides, del z. Now after solving this, we get cancelled. I v get cancelled. Left with del of u by del z plus I del v by del z. This whole thing comes after using this limit value and simplifying this del u, del v and del z. Right? Okay, now let's say we have two cases. Case 1 of on x-axis and case 2 on y-axis. So we all know that on x-axis y is equals to 0. So therefore f dash z is equals to del u by del x plus I del v by del x. On y-axis we have x is equals to 0, therefore f of z will be equals to del u by I del y plus I del v by I del y. Right. Now furthermore, case 1 will become f of z is equals to del u by del x plus I del v by del x. For simplifying that, we will get minus I del u by del y plus del v by del y. If this function f of z is analytic, then both of these cases will be same, and we can say that del u by del x plus I del v by del x is equals to minus I del u by del y plus del v by del y are equal, right? So equating the signs of I and another real terms, we will get our CR equation such as del u by del x is equals to del v by del y and del v by del x is equals to minus del u by del y. These are required CR equations in the Cartesian form, right? Now let's move toward the main concept that we are going to study today, which is the polar form. So now we are going toward the polar form. Let's say we are let's remember the previous things, that in Cartesian form we use x and y as a variables, but now in a polar form we are using r and theta in the whole concept. Let's learn some practical thing such as this is a graph, x-axis and this is y-axis. Let's say these are the variables in the Cartesian form. Now if I use this curve, as you can see, it's similar to the circle with having a particular radius r, and if I use a small diagonal over it, it describes a small angle theta. So here in polar form we are using this r and theta, right? Similarly, in a complex form, first of all let's consider a complex function that is u plus iv. So in Cartesian form we have z is equals to x plus iy, and in the similar case of polar form we have r e raised to power I theta, right? Now this f of z will be equals to f of r e raised to power I theta is equals to u plus I. Similar to the previous theorem, let's consider we are differentiating this f of z with respect to r. We will have e raised to power I theta is equals to del u upon del r plus del u upon del r. Again, when we apply this term with respect to theta, we will have r e raised to power I theta equals to del u by del theta plus del v by del theta. So sorry, we are using I here because u plus iv. Now comparing these two equations, we will get our answer. By del theta, we are just simplifying this term, minus I plus del v by del theta. comparing this form with this form, you will get your answer such as del u by del r plus I del v by del r is equals to minus I upon r del u by del theta plus 1 upon r del v by del theta. Right. Now equating all the terms, having the now equating all the real and complex terms, real and imaginary terms, we will get del u by del r is equals to del u by del r is equals to 1 upon r del v by del theta, and again del v by del r is equals to minus 1 upon r del u by del. These are our CR equation in a polar form.
Okay, so now we are going to solve an example related to the theorem we have studied earlier. Okay, so the question is, find P such that the function f of z expressed in polar coordinates as f of z equals to r square cos 2 theta plus I r square sin 2 theta is analytic. So here we have to find P, and we have given f of z equals to r square cos 2 theta and such on. Okay. So this type of questions asked frequently in GATE exam, so listen it carefully. So here we have f of z. So we can write as f of z equals to u plus ib, which is imaginary part and real part. Okay, so u is real part and v is imaginary part. So we can write this equation as u equals to r square cos 2 theta and v equals to r square sin theta. Now, in question we have given that this f of z is analytic, means it will satisfy polar coordinates. So the equation for polar coordinates in CR equation is del u by del r by del theta. So this is equation 1. Now we will derivate u with respect to r and v with respect to theta. Okay. So u will become del u by del r equals to 2r cos 2 theta. This is equation 2. Now differentiate v with respect to theta. So this will become del v by del theta equals to p r square cos p theta. Okay. So now equation 3. So we will put equation 3 and 2 in equation 1. Equation 2 and 3 equation 1. Okay, so equation 1 will become 2r cos 2 theta equals to 1 by r p r square cos p theta. Okay. By further solving this, 2r square cos 2 theta equals to p r square cos p theta. So as we see, 2 equals to p. So we have get the value of p. This is simple as that.